Okay, this is Measurement in Science. Our two big questions for this reading are why is a standard measurement system important and what are some SI units of measure? My Planet Diary. Measurements have helped people record and share information about some pretty amazing moments. In 2006, in Maui, Hawaii, a surfer rode the biggest wave on record, a 21-meter tall wall of water. Growers compete every year for the heaviest pumpkin in the United States. The 2009 winner weighed more than 725 kilograms. In the winter of 1909, a severe cold front hit the East Coast, including Florida. Tallahassee holds the record for the coldest temperature in the state, negative 19 degrees Celsius. So why is a standard measurement system important? Suppose you wanted to measure the width of a book. If you used your finger, the book might be 3 fingers wide. If you use paper clips, the book might be 5 paper clips wide. And if you used a ruler, the book might be 22 centimeters wide. These are 3 different ways of measuring the same thing. To avoid the problem of using different units of measurement, standard measurement systems were developed. A standard measurement system is important because it allows scientists to compare data and communicate with each other about their results. In the 1790s, scientists developed the metric system of measurement. The metric system is a measurement system based on the number 10. Modern scientists use a version of the metric system called the International System of Units, or SI. Prefixes are used to identify larger and smaller units. The prefixes used in the SI system are shown in Figure 1. So what are some SI units of measure? Scientists regularly measure properties such as length, mass, volume, density, temperature, and time. Each property can be measured using an SI unit. Length. Length is the distance from one point to another. A meter, or m, is the basic SI unit used for measuring length. 1 meter is about the distance from the floor to a doorknob. One tool used to measure length is a metric ruler. Many distances can be measured in meters. For example, you can measure your height or a soccer kick in meters. For measuring lengths smaller than a meter, you can use the centimeter, or cm, and millimeter, mm. For example, the length of a piece of binder paper is about 29 centimeters. For measuring a long distance, such as the distance between cities, you use kilometers. The table at the left shows you how to convert between different metric length units. Try measuring the green anole in Figure 2. Mass. Mass is a measure of the amount of matter in an object. In SI, the basic unit for measuring mass is the kilogram, or kg. The mass of cars, bicycles, and people is measured in kilograms. If you want to measure smaller masses, you would use grams, g, or milligrams, mg. The table at the right shows how to convert between kilograms, grams, and milligrams. The balance, shown in Figure 3, is used to measure mass. A balance compares the mass of an object to a known mass. Weight is different than mass. Weight is a measure of the force of gravity acting on an object. A scale is used to measure weight. When you stand on a scale, gravity pulls you downward. This compresses springs inside the scale. The more you weigh, the more the springs compress. Although mass and weight are related, they are not the same. The mass of an object is constant. It stays the same. The weight of the object is not constant. It can change because the force of gravity can change. For instance, on the moon, the force of gravity is weaker than it is on Earth. So you weigh less on the moon than you do on Earth. But your mass is the same no matter where you are. Here is the balance beam. Volume. Have you ever looked at a box of your favorite food and seen the following line, "This package sold by weight, not by volume"? Well, volume is the amount of space an object or substance takes up. All objects with mass, whether they are solids, liquids, or gases, have volume. In SI, the basic unit for measuring volume is the cubic meter, or m cubed. Cubic meters and cubic centimeters, cm cubed, are used to measure the volume of solids. The unit for measuring the volume of liquids or gases is the liter, L. The table at the left shows how to convert between these units. Calculating the volume of rectangular solids. Suppose you want to know the volume of a rectangular solid, such as the gift box in Figure 4. To find this volume, you would first measure the length, width, and height of the box. Then you would multiply length times width times height. When you use this formula, you must use the same units for all the measurements. Calculating the volume of liquid. In a laboratory, the volume of liquids is usually measured with a graduated cylinder, like this one. A graduated cylinder measures milliliters. Calculating the volume of irregular solids. Suppose you want to measure the volume of a toy car. Because of its irregular shape, you cannot measure the car's length, width, or height. However, you can use the displacement method. Fill a graduated cylinder 2/3 with water, place the object in the water, subtract the volume of the water alone from the volume of the water plus the object. Convert this difference into centimeter cubes to find the volume of a solid. Density. Two objects of the same size, such as a block of wood and a brick, can have different masses. This is because different materials have different densities. Density is a measure of how much mass is contained in a given volume. Because density is made up of two measurements, mass and volume, the SI units for density come from the units for volume and mass. The standard SI unit for measuring density is kilograms per cubic meter, or kg per m cubed. Other units of density include grams per cubic centimeter, g per cm cubed, and grams per milliliter, g per ml. Look at Figure 6. Density of substances. Different substances have different densities. Very dense materials contain a lot of matter in a given space or volume, while less dense materials contain smaller amounts of matter in the same space or volume. The density of a particular substance is the same for all samples of that substance, no matter how large or small. For example, a ring made of pure gold has the same density as a brick made of pure gold. The table in Figure 7 lists the densities of some common substances. Using density. If you know an object's density, you can determine whether the object will float in a given liquid. An object will float if it is less dense than the surrounding liquid. For example, the density of water is 1 gram per cubic centimeter. A piece of wood with a density of 0.8 grams per cubic centimeter will float in water. However, a piece of copper, which has a density of 8.9 grams per cubic centimeter, will sink. Use the table to answer the question about using density in Figure 7. Temperature. Is it hot or cold outside today? You can answer these questions by measuring the temperature of the air. Temperature is measured using a thermometer. A thermometer has numbers and units or a temperature scale on it. When you place a liquid thermometer in a substance, the liquid inside will increase or decrease in volume. This makes the level rise or fall. To determine the temperature, you read the number next to the top of the liquid in the thermometer. There are two temperature scales that are used in science, the Celsius scale and the Kelvin scale. On the Celsius scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. On the Kelvin scale, the lowest possible temperature is 0 K, or absolute zero. There are no negative numbers on this scale. The Kelvin scale is the basis for the SI temperature units, and the Kelvin K is the SI unit for temperature. Figure 8 shows a comparison of the Celsius and Kelvin scales. The table shows how to convert between the two scales. Time. The race is on and the finish line is in sight, but an opponent is catching up. Just 1 second can mean the difference between winning and losing. But what is a second? Time is a measurement of the period between two events. The second, S, is the SI unit used to measure time. In 1 second, light can travel about 7.5 times around Earth at the equator. Just like all SI units, the second can be divided into smaller units based on the number 10. For example, a millisecond, ms, is 1/1000th of a second. However, for longer periods of time, minutes or hours are typically used. There are 60 seconds in a minute and 60 minutes in an hour. Clocks and watches are used to measure time. Some clocks are more accurate than others. Most digital stopwatches measure time accurately to 1/100th of a second, as shown in Figure 9. Devices used for timing Olympic events measure time to 1/1000th of a second or less. And that is the end.